Today we're going to be jumping into our first part of trig, and we're going to start with converting degrees to radians and then also talking about coterminal angles. We'll need to write some of these notes down, so make sure that you have those ready as we look through here. First thing I want to take a look at is converting degrees to radians and radians to degrees. So here's some formulas we'll need to know. This is, again, how we convert from degrees to radians, and then we'll also talk about how to convert from radians to degrees. What I want you to notice, first of all, is it's the same formula. It's pi divided by 180 on one side, and then it's 180 divided by pi on the other. What we need to first recognize is what a full rotation is. A full rotation, we're usually very knowledgeable of degrees. 360 degrees is a full rotation. If we do more than that, of course, it's going to be two rotations would be 720, and then we keep going from there. And we also will talk about a little bit later that we also have negative rotations. We'll talk about the terminal side and the initial position, but we also need to first recognize that there's two ways of measuring rotation. One of them is the familiar degrees. But we also need to know a second rotation, which is radians. And a full rotation is 2 pi radians. This is the formula for the circumference of a circle because, again, this is another measurement. So when I make a full rotation is measured in two ways: degrees, which is 360, and radians, which is 2 pi. 2 pi radians is a full rotation as well. So when we want to convert from one to the other, what we need to do is either multiply or divide by pi over 180, essentially. Little note I have for you, put where you're going in the numerator. So if I want to go towards pi, then I need to put pi in the numerator. If I want to move towards degrees, 180 degrees is in the numerator, pi is in the denominator. So we'll put those into effect a little bit later. But this is the formula that we will use, pi over 180 or 180 over pi. And we're going to leave things in terms of pi, so don't give me a long decimal answer. If I learn that it's 1/3 pi, I need to leave it in terms of pi. So what we have here is what's known as the rotation, the positive and negative rotations. The initial side is pointing on a compass. This would be east. Pointing due east is our initial side. Some people use north as our 0 degrees, and in mapping, sometimes that is what it is. Navigation, that will be known as 0 degrees, but in algebra and most maths, this initial side is our 0 degrees. And our terminal side, if you think of it like a spinner on a game piece, if you're playing Twister, where the thing stops spinning. So the terminal side is right here. So if we have a measurement that has a terminal side that lands in this region here, that's the second quadrant there, that is a measure of 135 degrees. 45 degrees past 90, which is straight up and down, but this is also measured in another way. We could also rotate this in another way and get to the same spot. We'll talk about that when we get to the coterminal. But before we get into that, let's talk about the negative rotations. We probably didn't hear much in geometry about negative rotations, but if from this initial position, if our movement is down instead of up, a clockwise movement, that is a negative rotation. Counterclockwise is a positive rotation. Clockwise is a negative rotation. So we need to recognize that there are two types of rotations. So landing in the same spot, like we said on this angle here, sitting at 120 degrees, well, if I start here and finish there, there's actually an infinite number of ways in which that could happen. One is the obvious way, which is just to rotate 120 degrees as we see the blue arrow showing us here, 120 degrees rotation. A less obvious way is the negative rotation, that clockwise rotation, which would be negative 124 degrees. So that negative 124 degrees comes about by taking our angle, 120 degrees, and subtracting 360 degrees. That would be the negative rotation. So this would be the algebraic way of finding that negative 240 degree rotation. These are what's known as coterminal. Coterminal is another way of saying angles that are in the same location. I like to use the analogy, even though it's not an angle, but if you've ever seen Price is Right when they spin the wheel, you can have some marine up there and spin that wheel and it's going to spin like 6-8 times, and if it lands on $1, it's $1. You know, it doesn't matter that it rotated numerous times, it's where it ended up. You have a little old grandma that gets up there and spins the thing and it barely goes around a full rotation, but it lands on that $1. She won just as much as that big marine that spun it, you know, dozens of times or whatever happened there. So we also need to recognize that we do have multiple rotations that can take place. It's not just these two angles that end up with this initial side and terminal side. There's an infinite number of angles that can do this. We could have the same exact thing where we spun 360 degrees plus an additional 120 degrees, which would take us to 480 degrees. This is also coterminal to 120 and negative 240. You could add another rotation, 360 more degrees there, putting us, what would that put us at? 840 degrees. But this is another way of getting a coterminal angle. And we could also keep subtracting. We could subtract these as well with the negative rotations. So I can make this rotation full 360 plus that additional 240. So another coterminal angle to this would be the angle negative 600 degrees. And we could do this infinitely. We could just keep spinning this thing like a top over and over and getting new angles that are coterminal to one another. But coterminal angles are angles in standard position which have the same terminal side. Starting at the same spot, ending at the same spot, and their travels may be different, but that's what happens. So let's start talking about the examples of the two things we've talked about, one of which is converting from degrees to radians. Later on, we'll learn how to deal with a unit circle, and some of these degrees you may memorize, and that's great, but you don't have to. But when we don't have these, what we can do is use our measurements to convert them. So if I'm wanting to change this to radians, because it's already in degrees, what I would have to do is multiply times pi over 180. There's two ways of doing this. We can cancel them in place, or we can just multiply across. Let's multiply across initially here. So this would be negative 60 times pi, which is negative 60 pi, and 1 times 180, which is 180. And once we get here, we just reduce our values. The zeros cancel. 6 over 18 is 1/3, so this ends up being negative 1/3 pi. Another way of doing these, we still multiply by the same thing, because the way you get these is you multiply times pi over 180. What you can also do on these is cancel before you multiply, like the 80 and the 0, whether they 80 and the 180 both have a 0, so it goes this way. They are both even numbers, so I could factor out a 2, leaving this at 4, leaving this at 9. And then I can multiply across. I prefer to do it this way. Some people don't like to do it this way because it looks a little uglier, a little less clean. But we do 4 times pi, which is 4 pi, and then 1 times 9, which is 9. So 80 degrees is 4/9 pi. One thing you got to be careful of, a lot of people want to say pi, a full rotation is pi. Remember, pi is 180. Pi is 180. And we are slightly below half of 180. That's 80 degrees is, remember, 90 would be half pi. And of course, this is slightly below that with 80 degrees. So you can do a little check there. The other thing we can do is convert from radians to degrees. Well, the way we do this is we multiply by the complete inverse. I'm going to need to multiply this times 180 over pi. Now I'm going to do this top times top, bottom times bottom. You are able to skip that if you cancel these, but we're just going to we'll try to keep this as legible as possible. So that ends up being 360 pi, and this ends up being 3 pi. Anytime you have a number divided by itself, they cancel. In this case, that number is pi. So pi cancels pi, and then the 360 reduces to 120 with the 3. So you see everything cancels out here except for our 120, and this is 120 degrees. And let's think about our comparison here. 2/3 pi is 120. Remember the 60 degrees was 1/3. It's technically negative, but 1/3 was 60. If you double 1/3, you get 2/3. You double 2/3, or you double 60, you get 120. So keep an eye on that relationship between all of these. And then lastly, we've got the 4 pi here. Well, remember a full rotation is 2 pi. So this is the equivalent of 2 full rotations. So if you're pretty good with your rotations here, 360 is 1 rotation. Double that, you have 720 degrees. But we can also do it this way. We can multiply. Surefire way to do these things is just to multiply times 180 over pi. So the pi's are diagonal from one another, so you can cancel those in place just like I did. And then you do 4 times 180, that would be 720. 1 times 1, of course, is 1, so this is 720 degrees. All right, keep in mind as we do several of these rotations, because these rotations are going to show up in the unit circle as well. So the more you memorize, the more that you recognize, the faster you can work through these. It's not necessary to memorize these, but it will definitely speed things up for you.